correctly, then only we
Mm-hmm.
can solve. Is it there was like option was there, permutation used, combination used, and simultaneous order is important like that.
Yeah,
And
yeah,
also,
that's the thing. I mean, it's something like that. You have to identify which steps you are using. It's not like that. You have to. I mean, you are just doing your calculation blindly, right?
Yeah.
So thing is that AMQ is like you can clear your concepts. What's the things is going happen in the back end of permutation and combination, right? Normally we know we just apply the formula and we do the things, right? But
Yeah.
here it's like you have to identify whether events are occurring simultaneously or not, like that. Okay,
Yeah.
so that is the something. Okay, so I don't think what is the issue. I'm not able to open my C portal actually. Okay, so any one of you have, can you send me chat s- ID of the C portal?
Do you mean the portal to log in here?
Yes, Seek ID, right? That let me try again. I don't think what is the issue. I'm not able to open my C portal.
I have sent a link in chat, sir. Just see.
Okay, okay, sure. Just a second. Let me check. Very less people have joined this session. Is there any session happening simultaneously?
No, sir.
Not.
Okay, yesterday was the due date of week 5, right?
Yes, sir.
yes, sir.
Okay.
So, is there any way that you could request the team and they could extend it till tomorrow or something, or today at least?
For what?
The assignments?
It's done, right?
Yeah, it's
Week
done.
5.
But no, I'm talking, sir. Like, is there any way, sir, that you could ask them that we could extend it?
For week 5?
Yes, sir.
No, I don't think it's possible now. Because it's already due date is,
Okay, okay, sir.
so I don't think it's possible for now. And what is the due date for week 6? Then
Coming Wednesday.
coming Wednesday. Okay. Okay, so just tell me the question. I don't think why it's not opening in my ID. So what you can do, you can just tell me the question. We'll discuss the things, right?
Yes, sir.
Yeah, I don't think what is the issue is going. It's not opening for me. There might be some problem. But yeah, so just tell me the question where you have doubt. Okay.
So
So
no,
what we
graded
can do
assignment 5,
of week 5, right?
week 5. So there are 32 students in a class, and the teacher announced that the first 3 students
Yeah,
who complete the project.
just a second. Let me share my screen.
Yes.
You can send him the question in chat box, right?
Okay, I don't think this is the issue happening going. It's not opening for me. So what we can do, just tell me the question. I will write some question and we'll discuss the things. Okay.
Yes, sir.
Yeah. Okay.
There are 32 students.
1 second. There are
32 students.
32 students. Okay.
A class teacher announced that the first 3 students who complete the project within 2 days will be
Okay.
awarded.
Okay.
what are the possible number of ways the students will be awarded?
Students will be
Awarded.
awarded. Okay, so what was your approach?
Sir, my approach was that there are 32 students, and we could do it like filling. Say there are 3 spots, and we need to fill it. So 32, 31, 30.
32,
31,
31, 30.
30.
Okay.
So it was 32 divided by 29 29 factorial.
That means this, right?
Yes, sir.
Okay.
No,
So what
sir.
is this?
32 factorial divided by 29.
Yeah, this will become 32 factorial, right?
Yes, sir. Yes, sir. Okay.
So that's correct, right?
Yes, sir.
Is this correct answer?
Yes, sir. Yes, sir.
So I think numbers may be different for everyone. Okay. For someone it will be like 31 students or 42 students, like that. But
Yes,
yeah,
sir.
concept is the same. Okay.
Okay.
Okay. So see here, what we have done. We have done like since it's like, see, it's kind of position, right? Here order are matters, right? First, second, third kind of things.
Yes, sir.
Okay.
No,
So
sir. They've not said that. So order does not matter.
sorry, can you repeat?
They have not said that order matters. So we can assume, because they've said first 3. They have not said that first and then second and then third. They have not said that.
Okay.
The order
Okay.
does not matter here.
Yeah, then I think if order doesn't matter here, so what it will be, I think we have to multiply it by is this the correct answer?
Yes,
No,
sir. That's what.
sir, this is not correct.
Yeah, it's not correct. If order doesn't matter, then it's kind of combination, which is discussed in week 6. But here
Yes, sir.
we can apply here, right? So what we can do?
In
So can I
denominator, we can
divide?
multiply 3 factorial.
Sorry, can I divide by 3 factorial?
Yes.
Why,
Yes,
sir? Why, sir?
Hmm?
Why, sir?
Okay. So tell me, what is the meaning of these things? Suppose this is n factorial. So n factorial, n minus r factorial.
Yes, sir. This is
Correct?
NPR. Yes, sir.
Okay. Okay. And this is what gives you NCR?
N factorial by R factorial into N minus R factorial.
Why we are multiplying by r factorial?
Sir,
I mean, why we are dividing by r factorial?
I'm not sure, sir. I've not gone through the week 6 yet.
Okay. So that is the thing. I mean, see, here what we are doing, we are just considering the order, right? If you consider the order, right? I mean,
Yes.
why we are dividing by 3 factorial? Because those 3 can be anywhere, right? Suppose this is the first 3 students. Suppose this is first 2, 3, right? So it can be 3, 2, 1, right? It can be 3, 1, 2,
Yes.
2, 1, 3.
Okay, all of them are the same students.
Correct. So these
Okay.
all are the same, right?
Yes, sir.
So
Yes.
what we can do, we can divide by the 3 factorial, right?
Yes, sir.
Correct. So
Yes,
this this is nothing but, see, what we have done. We have done for, I mean, we started by the multiplication rule, but we reach in the case of combination one, right?
Yes, sir.
Are you getting what is the concept? Why we are
I
dividing?
understood the concept, but this is not wrong, right? So like they're doing it in week 6 and they gave it in grade assignment 5.
No. So it's not like I'm applying, just see, I use this formula just to and
Like,
I mean, so that you can understand, right? Thing
so,
is, suppose I don't know this formula. Okay.
yes, sir.
Forget
We'll
about
have to
this.
use the common sense and do it. But what
Correct,
happens
correct.
is, but this concept which you said that this concept was not taught in even the tutorial videos. I went through all the 8
No.
tutorial videos and
Okay. Listen to me. Okay. Can I do this or not?
yes, sir.
Yes, sir. You
For the
can.
Yes.
first 3 position. I
Yes,
know
sir.
Yes.
3 position doesn't matter, so I can divide by 3 factorial. all the possible cases? Correct?
Once
Yes, sir.
again, sir. Once again, sir. Once again, sir.
See, it just says first 3 students, right?
Yeah.
Correct? That
Yes.
means
Yeah.
first student, second student, third student, right? It's not like at the first position, this student is there, at the second position, another.
Hmm.
It's not, I mean,
Yeah.
position is not mentioned. We have to consider
Important.
just
Yeah.
first 3. Correct?
Okay.
So we have to
Okay,
consider
sir.
all the possible cases. First, 3, 2. I mean, it can be like that, right? It can
Yeah.
be
Yes, sir.
second, 3. I mean, these all possible. So
Yeah.
it total it will be 3 factorial cases, right?
Yes, sir.
Okay.
Correct?
Yes, sir.
Now, can I convert into factorial things? 29 factorial, right?
Correct.
32 factorial, 29 factorial into 3 factorial. That's all.
3.
It's just a simple logic, but yeah, it's a, you can relate you can reach the combination formula or permutation formula with the help of your multiplication rule as well. Okay.
Yes, sir. Okay, sir. So I have one more question, same assignment.
With 5-1.
Yes, grade 5. Grade
Okay.
assignment 5. There's
Hmm.
7, it's the second question. 7 classmates could not
One second.
agree.
Yeah, just read Sulu because I don't have question. Okay.
Yes, sir.
Just tell me. Yeah, 7 classmates, right?
Yes, 7 classmates could not agree on who would stand in a group photo along with
Okay.
the teacher.
Okay, I mean, they could not agree also.
Yeah, they could not agree who would stand with the
Okay.
teacher for the group photo.
Okay.
How many possible groups can be made such that there is at least one student with the teacher in the photo?
At least one student in the group photo, right?
Yes, sir.
Okay, so what was your approach for this one?
Sir, I was confused in this because we could have the gap method, right? Like one student, the teacher can uh, stand at
Okay,
the
so
extreme with the 7 students. Then in the middle, he has 6 positions. Then at the other extreme, so there were a lot of cases which came. That's why we got confused.
no. Why are you doing like this? See,
So,
tell me, what is the possible options for a student?
there are 7 students.
There are 7 students. That's okay. What is
Yes,
the
sir.
possible options? He can be either in the, see, what is the case? That particular student either can be in the group photo or not,
Yes, sir.
right? That means for a single student there are 2 options. He has 2 options. Either he can be in the group photo or not,
Yes, sir.
correct? Same
Yes.
for the second students, again he has 2 options.
Yes, sir.
For the third one also,
Yes, sir.
for the fourth one also,
Yes, sir. For
fifth
all
one,
5th,
sixth one, and
and
seventh one, right?
Yes.
So now it has been asked at least one photo, right?
Yes, sir.
Sorry, at least one student in the
One
group photo.
student. Yes, sir.
So for this, what is the total number of case? Total number of ways? 2 raised to power 7.
7. Correct, sir.
Correct. Now,
Yes, sir.
thing is that it has been asked at least one student. So what should be the next step?
Uh, at least one. 2 into 2 into 2 into 2.
Or this should be the answer.
So there'll be one case where all the students are not there. So that case should be deleted.
That's right.
Okay, okay, sir.
Got it?
Yes, sir. Yes, sir.
Yeah.
So but what was my okay. The other approach would be very complicated, right?
Yeah, it's so it's not
Okay.
asking positions of the students. It's just
Okay,
asking how many possible. I mean, in what is the total number of way? Anyways, this group photo can happen, right? So there are only 2 possible way for a single student, whether
Okay.
that student can be in the photo or cannot
Not.
be in the photo, right?
Yes, sir.
Okay.
Got
Is
it.
there any other
Sir,
question related?
why this answer is not like 7 factorial? Like if
Okay. When you will use 7 factorial?
when we are arranging the students.
So if
Okay.
if
Have you done this EMQ things? I mean, okay. So 7 factorial means what?
for the first position, like beside the teacher, the first position there will be 7 options, right? Then
Okay.
there will be 6 options.
Okay.
Then that's how it will go.
Okay. So you are doing like this, right?
Yes.
Okay. When in which scenario you have to use this? Whether you have to arrange the students at these places? Is this arrangement?
We are arranging all, sir. Means simultaneously it is happening.
Okay. We are not arranging kind of at a fixed places, right?
Yes, sir.
Yeah. It is
At
not.
least one
No.
student will be beside a teacher, right? So
Okay. So as per your
there will be 7 options. If someone standing beside a teacher, then there will be 6 options after that.
Okay, okay, one second. You are saying, suppose as per your concept, I'm saying at the first place, any of the 7 student can be there.
Yes.
Okay? At the second place, any of the 6 student can be there.
Yes. Yes.
Okay.
At the third place, any of the 5 students can be there.
Okay.
At the fourth place, any of the 4, any
Yeah.
of the 3, any of the 2, any of the 1. What about suppose he do not, I mean, he doesn't want to go in the group photo. Okay.
I mean, there are 7 students and they want.
What you are doing, you have arranged 1 student here, 2nd student here, 3rd student here, 4th student here, 5th, 6th and 7th. What about the case in which he or she doesn't want to go in the group photo? Are you getting? So this kind of case, factorial is nothing but, see, like that. In which scenario you can use? Suppose you have n objects, right? Okay, and you have to arrange these n objects, right?
The question is the same, right? There are 7 students, so how many ways can be done? Can that arrangement can be done?
Mm-hmm.
That's why I am saying that it will be 7 factorial.
No, it's not a 7
There
factorial.
are 7 students, and how many ways that they can stand that at least one will be beside the teacher.
Sorry?
The question is that how many ways 7 students can be arranged that at least one student will be beside the teacher.
Okay.
That's why I said that it will be 7 factorial.
No. What I'm saying, okay, as per your concept, we are not considering here the case in which scenario students will not be in the group photo. Are you considering those scenario?
But in the
Question
question
is
is not
question.
mentioned that
Sorry?
in the question that is not mentioned that someone doesn't want to.
No. Question in the question is mentioned, right? Who asked this question? I think Karthik, right? If I'm not wrong.
Jacob.
Yes. Someone asked this question. I don't think.
Yes,
Okay.
Jacob.
Yeah. So in the question, it's clearly mentioned there are some 7 classmates who could not agree, right? So it's mentioned. It's not like you have to arrange the 7 people at the 7 places. Okay. It's like, see, it's saying that there are 7 classmates or 7 students who could not agree. So there are 2 possible ways for a single student. These are total 7 students, right? 5, 6, 7. So first student has 2 options, whether he can be in the group photo or not in the group photo. Second student can be in the group photo or not in the group photo. He same for the third, right? These are the possible cases. So it's a two ways for the first student, 2 ways for the second student, 2 ways for the third, 2 ways for the fourth, 2 ways for the fifth, 2 ways for the sixth, 2 ways for the seventh, right? So what are the possible cases? Since it's nothing but 2 into 2 into 2 into 2 into 2 into 2, correct? There will be total 2 raised to 7 cases, and one case we will remove, will subtract, because there can be a case in which all the students are not in the group photo. So these are the total number of ways in which that situation can happen. I mean, these are the total, you can say, number of possible groups can be made such that at least one student with the teacher in the photo. Okay.
Sir, on this question, so
What is the, sorry?
Sir, on this question, if I think, if I approach this way, for example, for having one student, right, I have 7 options.
Okay.
Okay, for having two students, okay, any 2, right? So it can be like 7 into 6, which will be 42 options, right?
Okay.
Okay, so it will be 7 plus 42. Similarly, if I want to have
7
3
plus 42.
Yeah, because that
Okay.
is 7 into 6, right? So then if I have to have any 3 students, okay, then it will be 7 into 6 into 5.
Okay.
Okay, so if I approach this way, I mean, is this incorrect? Like, I mean, is there any systematic problem in this approach? Like, because I mean, here also, I mean, I if I consider this way, where at least one student has to be there. So I take like all 7 options, right? So either one can be there or all 7 can be there. All these intermediate states I calculate for each options and then do a addition.
Okay, so what is the answer? What was the answer?
No, I mean, I got a different numbers, but I mean, I don't have it handy with me. But yeah, if I approach this way, I mean, this will be definitely more than, I mean, 2 power 7 minus 1 will be 127.
Yeah, like that. Around
Yeah.
that.
So,
Yeah.
but then this number, I mean, this
The
approach
large.
definitely go
Okay,
more.
so just, yeah, great. Just to think like this, what you are doing just, you are considering all the students, right?
7C1, 7C2, 7C3, 7C4, 7 up to 7C7.
It's not actually a combination because I mean that was not.
Yeah,
thought
don't
right.
go in the combination. Okay.
So I didn't
So
go
what?
that way.
Yeah. So you are doing like this at the, you are considering any of the 7 students, right?
Correct. Yeah.
Then, or you are considering the case any of the 2 students, right?
2 students. So the possibility is 7 into 6, right?
7 into 6. But can I divide by 2 also?
Can I divide by 2? Yeah, I mean, this divide by 2 is the one that was missing in that week.
Okay, what you are doing, suppose you are considering this is the first student, this is second student, right?
Correct.
So
Yeah.
it can also at the first place, second students is there, first students is there, right?
Yeah, that doesn't matter. Correct. Yeah, order doesn't matter.
So just try in this way and see whether are you getting same answer or not. You got the point?
Okay. Yeah. I understood. Yeah.
Sir, why are you subtracting 1? Because it's given that at least one student should be there, right? So
Okay, so what is meaning? No, it's meaning at least one means in the group photo, in that photo, along with the teacher, at least one student can be there, right?
Yes.
Suppose there is one way in which there is not any student in that photo, correct?
So that won't be counted, right? Because according to the condition, at least one should be there. So we won't.
We have to no. Okay, so we have to consider the case in which at least one student is there. Okay, this 2 raised power 7 is the total number of ways in which group photo can be done, right? 2 raised power 7 means in this case, one case is also included already in which there cannot be there may not be all the students in this photo, right?
Okay, got it, sir.
Okay.
Got it.
So we have to subtract one way in which all the students are not in the group photo. So this total 2 raised power 7 minus 1 will give you the possible number ways for at least one student, right?
Okay. The individual teacher, the teacher
Correct.
only.
Yeah, teacher only. Okay.
Yeah, got it.
Okay, so
hello.
Is there? Yes, please.
Sir, regarding this problem, one more methodology to do it is that if you are using for each of those, see, there are 7 students, right? And as I think earlier this point came up, so 7 students, either and at least one student has to be there. Okay. So there could be either 7 students, or there could be 6 students, or 5 students, 4 students, 3 students, 2 students, okay, or one student with the teacher. But it's not the factorial thing that was earlier earlier suggested. The way I did was that if we take 7 7C1, 7C2, 7C3, and if we go on like that, then also we are getting the same answers.
Okay, so what can you mute? See, please mute those who are not doubt. Okay, so what you are doing? What is the meaning of 7C1? First off, tell me. Means 7 factorial, 1 factorial, 1 factorial, right? Hello.
Yes, sir.
Okay. So what is the value of 7 factorial? No. What did you say? Can you repeat?
So actually he said that we will be adding the values. So in first photograph we can have for all the 7 students, or we can have 6 students, or 5, or 4, or 3, or 2, or 1. So he's adding up all these values.
Like this.
7 plus 6 plus 5. Yeah.
Okay. So
This is even my question. Why can't we do this? Because this is, I think.
no. See. One second. What? Let me tell you. See, for what is the okay? Just solve this. Just solve this. I will tell you what is the issue. Okay. So this is the 7 factorial. You will get 7, right? So 7 from you will get 7 into 6. That means you will get something 21, right?
Yeah, 21. 7. Yeah.
And
Right.
for this.
So you are multiplying them?
No, we are adding, right?
Yeah. So 7 plus 6 plus 5. Just a minute. I think that would be equal to 28.
No, 21, right?
Yes, sir. 21. 7C to 21.
Correct. What is the 7C3?
35.
35. What is 7C4?
7C4 21. 35.
35. Because 7C3, 7C4 will be
Both,
same, right?
both are same. Yeah.
What is the
Plus
7C5?
21.
7C6?
7.
7C1 1, right? So it's the if you add, you will get something. 1 second. See, you got the same answer, right? So thing is that no, it's a correct one. Okay, what is the someone said this one, right? Who said? I don't know his name. Yeah. Hello.
Yes,
Hello.
sir.
Yes,
Yeah. Someone said this one, right? He was saying 7 student plus 7 or 6 students, right? Or
Yes.
7, 6 or 5, right? So
Yeah.
he was doing like this. Let me tell you. Okay, so 7 into 6 into 5 into 4 into 4 plus 7 into 6 into 5 into 4 into 3 plus 7 into 6 into 5 into 4 into 3 into 2. 1, 2, 3, 4, 5, 6, and at the end it will be 7 into up to 1, right? As per his approach, he was doing like that, right? Just a few minutes before, I told him we have to divide by 2, right? Because we are not considering the order, right? It can be this can be the first student, this can be second student, or this can be the second student, this can be the first student, right? So we have to divide by 2, correct?
Yes, sir.
The same thing is happening in this case of 7C2. So it's nothing but 7 factorial, 2 factorial, 5 factorial. So 7 factorial, no, 7 into 6 into 5 factorial, 2 factorial into 5 factorial, 5 factorial will get cancelled out. So what we are getting? 7 into 6 by 2 factorial. Correct?
Sir.
Yeah, right.
So for this, we have to divide by 3 factorial, right? The same thing we have done. Okay?
Yeah.
Now is this clear?
Yes, sir.
Is this clear?
Okay, sir.
Yes, sir.
Is
Yes,
it clear
sir.
for everyone, right?
Yes.
Okay.
Yes, sir.
Okay. So why we are not approaching like that? I mean,
So the combination
of
approach is also correct, right?
it's a correct, but it's these things has been done in week 6, right? So that's why we are doing
Yes,
at
sir.
concepts I mean which has been taught in the week 5, right? We are just
Okay,
taking.
okay.
Okay. So someone said this one, so I said just divide by 2. Next you have to divide by 3 factorial, like that 4 factorial and all. Is this clear?
Yes, sir.
Okay. Yeah. So any
Sir,
other? Hmm?
I have a doubt in graded assignment week 5, question number 9.
Question number 9. Okay, what is your doubt? I mean, what is the question? Can you tell me? Hello.
Hello.
11 digit university roll number.
See, I don't have question actually right now because
Sir,
I am facing some problem to opening my portal. So can you tell me the question?
sir, I have posted question in the chat.
Yeah, please.
Adam wrote down 8-digit university roll number on a piece of paper.
Okay, 8-digit roll number. Okay.
Away from his office, it rained heavily, and the paper got wet.
Okay.
Later, he saw that the first 3 digit of the roll number was disappeared.
First what? First?
So it is 9
First 3 digit roll
first
number.
3 digits. So it
Okay,
is
so numbers can be different for everyone. Okay, numbers is different for everyone. No need to worry about that. Okay, first 3 digits
of the roll number had disappeared.
disappeared. Okay.
In how many ways can Adam complete his university roll number if the repetition of digit is allowed?
Repetition of digit is
Allowed.
okay. Okay, repetition of digit is allowed. Okay, so what was your approach?
Sir,
Your voice
first
is,
we have
yeah,
to be check the whether first 3 digit of the uh,
your voice is breaking. You are not audible right now.
May I tell, sir?
Yeah, please go ahead. I mean, how did you approach to this question?
Yes, sir. Yes, sir, we have to fill the 3 digits, okay? And the repetition is allowed.
Okay.
And that total, it is a total 8-digit roll number, okay? So the first place is filled by 9 places. I mean 9 ways, in 9 ways, excluding the 0.
Excluding the
0.
Okay.
Then second option is filled by can be filled by 10 in 10 ways.
Okay.
And third one in 10 ways too.
Okay.
Because the repetition is allowed.
So as per your answer, it should be 9 into 10 raised power 2. I mean 900.
Yes, sir. Yes, sir.
Okay.
Yes,
Okay.
sir.
So is this correct answer?
No, sir.
Right?
The answer is yes.
answer is
why
1000.
not the first can be 0? 10 cube.
So correct answer is
yes, sir. Thank you.
okay. So first tell me, it's a 8-digit roll number, right?
Yes,
Yes, sir.
Correct?
No, 11 digit.
Earlier I said
different data.
numbers are different for everyone. Okay. So
Okay.
just try to understand the concept. Okay.
Sorry, sir.
So it's a 8-digit roll number. Yeah, no worries. So it's a 8-digit roll number. Okay. So can you tell me, those who have not doubt, see, those who are not doubt, please keep mute yourself. Okay. There are some background noise continuously coming up. Okay, just unmute when you have doubt. Okay, so it's a 8-digit roll number. Okay, so tell me, suppose I said your roll number of your class is 01. So is it digit roll number or 1 digit roll number?
It's one
Correct,
digit.
sir.
Sorry?
Sir, 1 digit.
No, don't. Okay, so tell me, first of all, roll number is a categorical variable or numerical variable?
Categorical variable.
Categorical, sir.
Categorical, sir.
Roll number is a categorical variable, right?
Yes.
If
Yes,
it's a
sir.
categorical variable, suppose I said, then it matter about you are considering it as 1,
No, sir.
right? So it's a categorical variable thing, right? There is no meaning of mathematical concept, right?
Yeah.
Okay. So suppose I said your university roll number or your class roll number is let's say 0, 1, 2. Okay. So it's a 3-digit roll number or 2-digit. Don't
This
think
is a
as numerically.
3-digit.
It's a
3-digit,
3-digit
sir.
roll number, right?
Yeah.
Suppose
Yes.
in any suppose your roll number is like that A21, correct? So it's a 3-digit or 2-digit.
3-digit.
So since it's a categorical variable, okay, so don't think like a numerical variable, okay. That's why I think this option has been given to confuse, right? I mean, you got the answer. You will think like it's correct. So it's a 8-digit roll number. So for the first place we have 10 options. Again for the second place we have 10 options, and for the third place again we will have the 10 options. So correct option is 10 raised to power q. Okay. Suppose it's a password instead of roll number. It's a 8-digit password, and you have to fill the first 3 digit. Correct.
Yes, sir.
Password or say something some numerical thing. You can think some numerical thing you can so you have to consider that at the first place it won't be 0. For the second place you have to consider all the case. I mean some numerical thing, right? So you got
But
the point.
so why for password we can't have a 0? We can, right? We can't add or subtract passwords. It's categorical, right?
That's why I said think some numerical. Okay. I did not say password for the etc. Okay.
Okay.
So
Okay.
is there any if there is any numerical thing in which we are not okay? Let's see. I'm going to make the 4-digit number, right? Okay. Okay. Suppose
Okay.
let's say you have 5 places. I said last 2 places has been filled by 2 and 1. Okay. And I said
Okay.
you to make this 5-digit, you have to fill this 5 let's say 5-digit number. Okay. And repetition is allowed. Okay. So can I place 0 at the first place?
No.
sir.
No, right? That is we have 9 cases. Then for the second I have 10 cases. For the third place I have 10 cases. So these last 2 places has been filled out, right? So it's a like that. Okay. So roll number is nothing but it's a categorical variable. Okay? That's why we are not doing. Is it clear?
Yes, sir.
Okay. Any other question from the graded assignment? Of week 5?
So, sir, the previous question, where we discussed, so I calculated that with the approach that I explained. So, yeah, I got the same answer, 127. Okay. So,
yeah, this one, right?
Yeah, that one, correct.
Yeah, we have done.
Yeah, so here, and so what I understand is, so in this question, we should consider as order doesn't matter, right? That's where.
Yeah, correct. Because okay, someone who okay, can you tell me name who told me this approach?
Pradeep here, sir.
Pradeep. Okay. So what you have done? Okay, so you said at the first place there are 7, right? Or at the second you are considering 7 into 6. So what is the meaning of 7 into 6? You are fixing the position. You are considering the order of the position, right?
Correct. Yeah.
But it can be interchanged. So we have to divide by 2 factorial plus 7 into 6 into 5.
Yeah.
We have to divide by 3 factorial.
Correct. Yeah.
And so on, right? So this is the same as also it's like say out of 7 students, 1 student can be there, right? Or out of 7, I mean, see, for some people this combination might be confusing. So don't worry, it's in week 6. So we are doing the same question in different approaches. Okay. So what we can do? So we can select at 2 students out of 7, 3 out of 7, or 4 out of 7, or 5 out of 7, or 6 out of 7, or all are in the group photo, right? These are the possibilities. Okay. So what is this? 7 factorial, 1 factorial, 6 factorial.
Yeah.
7 into 6 factorial, this will get cancelled out.
Yeah, this will become
So
7.
what you got? You get 7, right?
Yeah.
If you solve 7 factorial,
this
2
will
factorial,
be
5
21.
factorial.
This will be
7
21.
into 6. Okay. So this is the same as 7 into 6 into 2 factorial.
Yeah.
Okay. What about this? 7 factorial divided by 3 factorial into 4 factorial, right? So I can write down 7, 6, 5 into 4. 4 will get cancelled out. Okay. So what I got? 7 into 6 into 5 divided by 3 factorial. Right?
Yeah.
The same thing we are doing here. Okay.
Yeah.
Okay. Or another approach, the final one, as per the concept of week 5, there are total 7 students, right? For each student, there are 2 possible ways, whether he can be in the group photo or not. He can agree for in the group photo or not. He can be agree on the full group photo or not. So there are 2 ways for each of the students, right? So there are total 2⁷ ways in which that group photo can be done. But we have to subtract one case because we have to consider at least one student in the group photo, right?
Yeah.
That means one way we have to subtract in which there is no student.
Okay.
As you see here, we are considering, we are not considering 0, 1. We are considering 1 student, 2 students, 3 students, 4 students, 5 students, 6 students, and 7 students. Okay.
Okay.
Is this clear?
Yeah, this is now clear, sir. I mean, I missed that part of. I mean, considering that order doesn't matter, right? So I mean, that is where I'm getting confused when I try to apply this addition and multiplication. So I mean, I'm kind of getting confused with the order matters and order doesn't matter, because most of the questions, especially in the EMQ part, right? I mean, all are like. I mean, I could consider all as either order matters or order doesn't matter. That
No. Okay. Let me give you an example. Suppose something, there are 10 people. Okay. And I have to choose 2 people.
Okay.
Okay. In how many ways I can choose 2 people?
10 people, choose 2 people. So yeah, it will be 5 into, sorry, 10 into 9.
10 into 9.
Yeah.
No, I have to choose only 2 people.
Okay.
So divide by 2 factorial. I'm not saying, okay, I can choose any 2.
Any 2.
Suppose I choose first and 2. Okay. Suppose I choose, okay. What is the meaning of only selection? I'm saying I have to select 2 people out of 10. Means it can be P1, P2, right? Or suppose I said P2, P1. So these 2 are same.
Same. Okay. Okay. That's a kind of selection and arrangement. That's a kind of.
Yeah. It's just a selection.
Okay.
Suppose I first select P1, then P2. Or I can select P2 and P1. These 2 are the same. At the end, at the final stage, I have selected person 1 and person 2. Order doesn't matter, right?
Okay.
Okay. So this is something, this is nothing but the 10C2, correct?
Okay.
That means the combination.
Okay.
So far it is clear? Now,
yeah, it's clear.
Suppose I said out of 10 people, I have to choose 2 people in which, suppose one is the captain, okay? And one person is the vice captain. So what we have to do here?
So it will be 10 into 9 then here.
10 into 9, that's all. Because we are considering the order here, right?
Right. Yeah.
Okay. No need to divide by 2 factorial.
Okay. Got it.
Because suppose I said person 1 is the captain and person 2 is the vice captain. Okay. So this thing is different from, suppose I'm saying person 2 is the captain and person 1 is the vice captain, right?
Okay.
So what is this? this can I write down as the 8 factorial divided by 8 factorial. So it's nothing but 10p8. Sorry, 10p2
Okay.
permutation thing, right?
Okay.
Is this clear now?
Yeah, it's clear, sir. Yeah. Okay.
Sir,
Yeah, please go ahead.
sir, I have a question. I have a doubt in a graded assignment question. The question states that 8 students went to watch a patriotic movie. An analyst want to know whether they like the movie or not. Each student has the option to refuse to respond. In how many possible
Okay. Hello. You are not audible if you are
Question is,
speaking.
sir, in how many ways can the analyst get responses from the students?
Yeah.
Okay. What are the total number of students?
8.
8. Okay. And
So,
can you
sir,
repeat the question? Can you repeat the question?
yeah, sure. So there are 8 students. Okay,
Okay.
they have went to watch a patriotic movie, and
Okay.
analysis want to know whether they like the movie or not. Okay,
Okay.
each student has the choice to refuse to respond. In how
Okay.
many ways can the analysis get the response? So, sir, for this, what I did, I thought that each student has 3 options. One
Okay.
is either they like the movie, second is to say they don't like the movie, and third is not to respond. So in that way I got 24 as the answer. So is that correct?
How many what answer you got?
24.
So you have done only 3 into 8.
Yeah, 8 students are there and each have 3 options, so I multiplied them.
No. So you have done wrong thing, because okay, your approach was correct. Okay, there are total 8 students, right?
Yeah.
5, 6, 7. Your approach was correct. For a first student, he has 3 options, right? He can
Yes.
like the movie, don't like the movie, and refuse the response, right?
Yeah.
Same for this one. 3 ways. 3 ways for this, 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 3 ways for the 8th student, right?
3 raised
Okay.
to 8.
3 ways to each, correct?
Yeah.
So
Yeah.
for all the students, in how many ways you can get? It's not you have to add, you have to multiply it by each 3, right?
Okay. Yeah. 3 to the power 8.
8,
Okay.
not 3 into 8.
Okay. Yeah.
Okay. Its question is not like from the first student or second student or 3 student, right? It means total number of in which that analyst can get the response from all the students.
Yeah, sir. Got it. Got it. Okay. Yeah. Thank you.
Okay. Is there anything else from graded assignment of week 5?
Sir, EMQ2.
I mean, I don't have, actually, I'm facing to open my portal.
Sir,
Showing something dashboard. So just tell me the question. We'll discuss the.
sir, sorry to interrupt. Before we may move on to the next question, I mean, if I could have a follow-up question on the previous one, what we discussed. So the 3,
Okay.
right? So I mean, if I approach this problem like this, like say, if a person choose to answer, I mean, choose to vote, right? Then he can either like or not like. Then he can choose not to respond.
Can you repeat? Can you repeat?
I mean, if a person chose to respond, he may choose either like or not like. So there is 2 options. Okay. Then each person can choose not to respond. So in that case, there will be another option, right? So if I take for each person, can I take 2? I mean, sorry, 2 into 2 into for each person, plus say one option each for each person. So can that be added?
One option?
I mean, because it's an or option, right? So I mean, say like, not like, or refuse.
No, if you say like, not like, or refuse, so he has 3 options, right? A particular person can like the movie. It's not like at the same time he like the movie or don't like the movie, right?
Okay.
Suppose I said, suppose you watch movie, any movie, right? And suppose I'm an analyst and I exit get of that theater hall, okay? And you came out from the hall, and I asked you whether you like the movie. I mean, you have three options, right? Either you can say yes, no, or I mean, you can't give any response, right?
Okay.
So these are total three options you have. You can do either you can say I like the movie, I did not like the movie, or you, I mean, you said, I mean, you refuse to give the response to me, right?
Okay.
Okay. Suppose there is no option of refuse to response. It's a compulsory kind of things, right? Suppose you
Okay.
fill a Google form or anything, there is something compulsory thing. There are only two options, like or not like. Then for each student, he has only two options. Either he can like or not like.
Okay.
Okay.
Yeah, so what I mean is, say for example, I mean a person has first to start with, right? A person has two options. I mean, if I take this approach, for example, if a person has two options, he can choose to vote or refuse to respond. So in which case each person has two options. Okay, which will bring it to 2 power 8 options.
Yeah, it's the two options, right?
Yeah, I mean, yeah, sorry. What I mean is, I mean, say all three options are available. For example, if a person can like or not like or refuse to respond. So there are three options provided, right? So in that, say I'm approaching a problem this way. For example, in this case where three options are available for a person, first is to start with a person can decide to vote or not to vote. In that case, a person has two options. So which means 2 power 8.
Okay.
Out, and then plus when the person has chosen to vote, in that case he still has two options for each, so which means it's plus 2 power 8. Is this a right approach?
Actually, I'm not getting what you're trying to say here.
Okay.
Okay, can you explain a little bit?
Yeah. Sorry. Yeah. So see, I'm segregating the answers in this way because in the question it was mentioned that, like, say a person can like or not like or refuse to respond.
Okay.
So I'm clubbing like and not like as option 1 and refuse to respond as option 2, because I'm considering this as option 1, which is like or not like, as a person is deciding to vote for it. Okay, in that case, it's either like or not like. So I mean, eventually I'm clubbing that as an option 1. So in which case a person has two options: vote or refuse to vote.
I mean, like or not like.
I mean, like or not like is an option. I mean, one option I'm considering. Okay. To start with, I'm clubbing like and not like as option 1 and refuse to vote as option 2. So in which case each person has two options to start with. In that 2 power 8 options, all 8 will get 2 power 8 options. Then if a person has chosen to chosen to like or not, I mean, chosen to vote, in that he has two more sub options.
Okay.
Okay, so which means it will be plus 2 power 8.
So plus 2 raised power 8 or into 2 raised power 8?
That is where, I mean, because I was considering as plus 2 power 8. I mean, if I think that way, is that a right approach?
Okay, I need to check on it, because you are clubbing the things, right? Like, did not like, and you are considering it as 1. Suppose saying, let's say, make it as R1 and make it as R2, right? Then you are considering, okay, so what you have to do, you have to consider this R1 and R2 also, and inside the R1 also, right?
Right. Yes.
Yeah. So okay, I will check on this. Okay.
Okay, sir.
I will check more on it,
Okay,
whether
sure.
it's the correct one or not. But yeah, I mean, do you get this one, the final one?
I think no, I'm not getting that. So that's where I got confused.
No, 3 raised power 8 1.
Yeah, 3 power 8 is correct, but yeah, I need to on this splitting.
Okay. You are thinking this approach, okay?
Yeah, correct. Yeah.
Okay, so for now, okay, I will check on more it. Okay, I will think whether it's correct or not. Okay, because there might be cases, right? If you are clubbing the things, there might be cases where whether we have to add or whether we have to multiply it. Okay. I will think more on it and we'll let you know. Okay.
Okay.
Or
Sure.
else you can post on the discussion. We'll see it later.
Yeah. Sure, sir. Yeah. Thank you. Thank you.
Yeah. Thanks for this. It's I think we can think more on it, and the rest of the people can explore this approach also. Okay. Just try to think. I think it's a good one. We'll see this. Okay. Thanks for this. Yeah. Anything else from the week 5 graded one?
My question was, sir, that Pradeep sir has said in the previous one that follow R1 and R2. That approach is like in that clubbing, each student have to go through the like and dislike, even though he has chose not to respond. Is that correct, sir? So, for example, I am going to R2. For example, I am going to R2. Still, I have to choose like or dislike. That's
okay. That's why I said just explore it, explore more on it. Okay, we will also think on it. Okay, that's the correct one, or whether it's. I mean, wait, this may be correct. We have to think. We have to think all the possible cases. That's all. Okay, answer we will get. I can say. Okay, answer we will get, but we need to think the possible cases. Because in this scenario, sometimes we forgot or we missed out some cases, okay, which we need to consider in our calculation. But yeah, okay, just think about it more on it.
Sir, my question is, Ram has n trophies that he wishes to place in his main cabinet.
One second, just a second, because I don't have question. Okay, so just tell me little bit. So okay.
May I start?
Yeah. Please go ahead. Yeah.
Ram has n trophies that he wishes to place in his main cabinet, which has space only for 2 trophies. If the number of trophies is increased by 3,
just read little bit slow because I don't have question, right? So I need to write the things. Okay, so n trophies and 2 places.
2 places.
Okay.
If the number of trophies is increased
These
by
are
3,
the empty place, right?
Yes, sir.
Okay. Yeah.
If the number of trophies is increased by 3, the number of possible ways to arrange the trophies in the main cabinet becomes 5 times the number of ways to arrange n trophies. May I repeat the question?
Okay. Yeah. Please go ahead. If
the number of trophies is increased by 3,
if the number of trophies
is increased by 3,
okay, increased by 3, okay,
then the number of possible ways to arrange the trophies in the main cabinet,
number of possible ways to arrange the trophies in the main cabinet, okay,
becomes 5 times the number of ways to arrange n trophies.
Okay. See. Okay.
So the question is, how many trophies does Ram have?
That means value of n, right?
Yes, sir.
Okay.
So
can
how
we,
to approach? No, I did not attempt, sir.
Okay, you did not approach. Okay. So as per the question, in how many ways Ram can place his n trophies in the main cabinet?
Yes, sir.
N into n minus 1, sir.
Number of ways in which Ram or Sam can place his n trophies, right?
Yes, sir.
Yes, sir.
His n trophies in the main cabinet, right?
Yes.
In how many ways he can do?
N minus 1.
Why n minus 1?
Because if he places an nth trophy, then he will not replace. I mean, repetition is not allowed in this case.
In the main cabinet, he has only 2 places, right?
Yes, sir.
So you can do like that, n into n minus 1, right?
Yes, sir.
For the first place, he can place any of the n trophies and n minus 1 trophy, right?
Yes.
Now, question said number of trophies is increased by 3, right?
Yes.
if number of trophies is increased by 3, then in how many ways he can place his trophies in the main cabinet?
9 plus 3 into 9 plus 2
9.
plus,
I,
sorry, n,
N
sorry.
plus 3.
Plus
N
n
plus
plus
3, no,
3
sir.
n plus 2 into n
Okay,
plus 2, I
Yeah.
think.
means n plus 3 minus 1, that is n plus 3 into n plus 2, right? Okay, this is the
Yes.
case when number of trophies increased by n. This is the case when he has only n trophies, right?
Yes.
Now, as per your question, he said number of trophies is increased by 3. Then the number of possible ways, what are the question? Number of possible ways to arrange the trophies in the main cabinet
Increased by 5
increased
times.
5
5
times.
times. Okay. So what is the as per the question, what I can write? I can write 5 times n into n minus 1
Equals.
is same as n plus 3 into n plus 2.
Okay, we have to solve that equation, no?
Correct, correct. So do
Okay.
I need to solve?
No.
Okay.
Thank you, sir.
So okay, is this clear now?
Yes, sir.
Okay, great.
So
Yeah, please go ahead.
actually, over here, what I did, I actually considered the total number to be x. So what I did, I made two equations out of it. N into n minus 1 is equal to x. And second equation as n plus 3 into n plus 2 is equal to 5x. So by solving that, I got the answer as 3. So is that approach correct? I assumed it the total number to be x, and then the number after adding plus 3 to be 5x.
Okay, so what we are do you are done. You are done like
I made two
5x.
equations. Yeah, n into n minus 1 is equal to x.
So it's a 5x equal to n plus 3.
Into n plus 2. Yeah, 5x is equal to n plus 3 into n plus 2.
Yeah, so I don't think you will get wrong answer. I think you get the correct answer. At the end, you have to place the x as n into n minus 1, right?
Yes, right.
So yeah, this is. I mean, what you have done, you just replace this quantity by x, right? If
Yes.
you are as per your concept, if this is x, then it should be 5 times x, right?
Yeah, right.
Yeah. So at the end, you have to replace this x by n into n minus 1. Okay, that's a good. Okay.
Okay,
Yeah.
fine.
Is there any other question from week 5 graded or anything else from week 6?
Yes, sir, I have one.
Yeah, please go ahead.
Yes, sir. You told the approach. I have week 6 activity question number 1. As you told the approach in the previous question, there is a question in how many ways that can a test paper of 6 questions can be attempted, each question of being true and false type. Okay.
Can you repeat? Can you repeat? Because I don't have a question for right now.
In how many ways can a test paper of 6 questions be attempted, each question being of a true and false type? Okay.
Okay.
As you told in the previous question that I go by that approach, that every question that each question has two choices. It should be attempted or not.
Okay.
Then every question has two, and we have to attempt the all 6 questions. Then as per my approach, the answer should be 2 raised to the power 6. But answer is 720 something, 729.
Okay. So you are saying, okay, suppose you have one question, right? Of true or false kind, right?
Yes, sir.
What you have okay. So you can do either true, either false. Okay.
Yes, sir.
So this okay, and one more way. You did not attempt this question. You did not attempt this question means you have not select any option for that question.
But sir, it is telling that
What is okay? What is the meaning of attempting a question paper? Okay. Suppose I have given you a question, right? Yes, sir. And you have to fill whether it's a T, whether it's a false, right? And
Yes, sir.
you, okay. Suppose you written as a false. That means you attempted that question.
Yes, sir.
Okay. And you did not write anything in that scenario. You did not attempt the question.
Yes, sir.
Okay. So at the end, you have 3 ways, right? Just think like that. Okay. It's the meaning of attempting a question paper. That's the different thing that okay. In this, it was clearly mentioned like, did not like, refuse to respond, right? So that's why we have clearly mentioned like, but in this case, did not attempt. Okay, attempting the question paper means you have not filled the true, you have not filled the false as well. Anything, right?
Yes, sir.
Is
Yes, sir.
it
I'm
clear now?
struggling with. Yes, sir. I'm struggling with the permutation and the combinations too much. Could you suggest me anything? How can I improve that?
Okay, just I mean, first of all, I can say, just practice the more questions which I have given already. And apart from this, if you want, then you can try the NCRT books of 11th and 12th class.
Okay, sir.
Yeah, just do the more questions, and don't see the solution before. Okay, if you see the solution, you will say like, you will be like, yeah, I can do. But
Yes,
just
sir.
read the question, try to think in the more different approaches also, right? Whether I can do like this, I can do like this or not. And
Yeah,
then
yeah.
solve it, then see the solution whether your solution is correct. If you solve the, okay, suppose you solve the question and you got a correct answer, right?
Yes,
Now
sir.
just give some more time and think whether you can approach different way or not,
Yeah,
right?
okay.
If you see that group photo one, we have done like 2 raised power 7 minus 1. Someone said no, I can do like at the first, it's 7 students there, or 7 into 6, or 7 into 6 into 5. And
Yes, sir. I've tried this approach too, but you told we have to divide by two. Then
correct. So thing is, suppose you tried this and I told no, it's not correct. You have to divide by 2 factorial, because
yes, sir.
order doesn't matter. So just try to approach the question in different way.
Yes,
The
sir.
more question you will solve, you will get the clear idea. Okay.
Okay, sir. Thank you,
Okay.
sir.
Yeah, great. Okay. Is there anything else from your
Yes,
side?
sir. Yes, sir. Yes, sir. From EMQ, one question, sir. Shall I read?
Okay. Yeah, please read.
Pragya wants to make distinct sequences using the 2J letters and 5K letters.
2J later. Is it from practice or something?
It is from EMQ bonus practice.
Okay. 2J letters and 5K letters.
Yeah. On the basis of given information, answer the questions 3 and 4. The question 3 is, from the given list of options, select the steps applicable to make the distinct sequences.
Okay, so 7, there are, we have to make the word of 7 letters.
5 plus 7, yeah, correct. Total 7. Yeah.
2J and 5K, okay.
And they are distinct sequences.
Okay.
What are the possible number of distinct sequences Pragya can make?
So you are asking number of possible sequences.
Yeah.
Okay, so what is the correct approach from as per your?
So she a total 7 letters are there, and she can select simultaneously. But with or without a replacement, sir. Distinct means without a replacement, correct? No.
So distinct means, suppose you're 2J's, right?
Yeah.
So you are considering these two as distinct means, suppose at the first place just think this is J1 and this is J2, right?
Okay.
So these two are you are considered as distinct. Suppose I'm saying these two are identical means, suppose I will say this J2 and J1, that means it's same as J1. I mean these two are the same. Okay.
Okay.
So we
Okay.
are considering these two means, suppose I place J1 and J2, that means these two are different. Okay.
Okay.
So 7 factorial by 2 factorial into 5 factorial is the correct answer.
Yes, sir. Yes,
Okay.
sir.
So as there are this concept in week 5, I don't remember, but it's something like that. You have n letters, then you can arrange. Okay, and if there are some letters of one kind, you can do it by 2 factorial, and another letters are the same as the second kind, so you can divide by the 5 factorial. Is this in week 5?
This tutorial is in week 6, sir, but I think
Okay.
EMQ is asked in week 5.
Yeah, EMQ is asked in week 5, but what's the thing you can do by the counting principle and all things also, right? Yeah, but thing is that you have to just think a little bit more. If order doesn't matter, then I have to divide by some that number of cases, that let's say 2 factorial, 3 factorial, like that. But yeah, so it's like that. So it's question has been designed like that. You will be able to know how you can reach multiplication rule to permutation or combination, which things has been discussed in week 6 also. Okay.
Okay.
Yeah, great. Okay, is there anything else from week 5, week 6?
Sir, there is a one in activity question, grade 6.1. So the question is like, how can we, in how many ways can 5 distinct books be arranged in 2 bookshelves?
5, just tell me the question. 5 distinct books, right?
5 distinct books be arranged in 2 bookshelves.
2 bookshelves, right?
Yeah, in 2 bookshelves. Yeah, correct.
Okay. So what was your approach?
I mean
how?
2 bookshelves, I got confused. Then yeah, I mean 2 bookshelves means I assume it's 2 racks. So probably, I mean, I would think this way, like all 5 books can be in one rack, then one in rack 1, 4 in rack 2, 2 in rack 1, 3 in rack 2, 4 in rack 1, 1 in rack 2.
Okay, yeah, okay. So what? Yeah, great. So that's the case, right? Because case 1 can be 5 books, let's say in the first bookshelf, right?
Yeah.
So in how many ways you can arrange the 5 books in the first book? 5 factorial?
Yeah, so that's where, I mean, one thing which I got confused here is like, okay, I mean, 5 books can be arranged in shelf, but now does the order matters? I mean, because I mean it's in the same shelf, so I mean if I put in any place, would that matter? That order matters always confuses me. So I don't know if that is actually 5 factorial or just one option.
No, not one option. Okay, suppose you place in a rack. Okay, suppose this is rack 1, this is rack 2. Okay,
right.
So you push. Okay, I can see. I have to. What was the question? In how many ways I can arrange 5 books, right?
Right.
So it's possible. I can arrange. I can arrange all the 5 books in the first bookshelf, right?
Correct.
Okay. Suppose in that first and 0 number of books in the second.
Yeah.
Okay. So for the 0 means in how many ways you can arrange a 0 book?
That is 1.
That is 1. Okay. So at the end, I have total 5 factorial ways. Correct?
Yeah, this I understood now what you are explaining, but my confusion is like, okay, why it is, I mean, why 5 factorial? Can't it be just one option? Because I mean, I'm keeping all 5 in a shelf. Does the order matter? I mean, if B1, B2, I mean, there is no any kind of ranking or anything here, right? So it's like I'm keeping 5 books in a shelf. So
okay, suppose I'm saying you have n distinct things, right? Okay, so what do you meaning of arrangement? It's clearly says you have to arrange the thing, right? It doesn't mean you select the n things and you place at the one place.
Okay.
Okay, I have some n object. Okay, I have some n distinct object. I have to arrange these n objects at the r places. So at the r places means what? In how many ways I can arrange? For the first place, I can arrange any of the n objects.
Yeah, it's
for the second
NPR. Yeah, it will be NPR.
It will be NPR kind of things, right?
Yeah, correct.
So the same thing. That's why in the question, I think as you have read the question, it's mentioned that in how many ways I can arrange, right?
Yeah, correct. It is, yeah, it is mentioned arrange, but yeah.
Yeah, so just think like that. I think you are getting confusion. Like if it's in book, then why I'm not considering as one, right? But that those books you can arrange also. I mean, that's why it's mentioned in the question already. In how many ways you can arrange, right?
Okay.
So for the case two, what you can do? 4 books in the first book shelf and 1 book in the second, right? Correct?
Okay.
Okay.
Yeah.
So how many ways you can arrange the 4 books in the first book shelf?
4 books. Yeah, it will be 4 factorial, right?
4 factorial, right? What about one? Sorry. What about one book?
It will be 1 factorial.
1 factorial or any of the 5?
Yeah, any of the, correct. Yeah. It can be any of the 5. Yeah.
Any of the 5, right? One book means any of the 5. Out of the remaining 4, I can arrange in the 4 factorial ways. And then I will get 5 into 4 factorial ways, which is again 5 factorial.
Yeah. Okay.
What will be the case 3? 3 books in the
Yes,
first.
sir. How is the 5, sir? Can you tell me again?
Okay, I said you have 5 books, right? And you took arrange at a place. Then I can choose. Okay, I have 5 options. I can take any of the 5 books, right?
Yes.
Okay, that's why it's a 5. So second case can be 2 books. Okay, 2 books in the first book shelf and 3 books in the second. Correct? In how many ways you can arrange 2 books in the first book shelf?
Two books, it will be 2 factorial.
2 factorial.
Sorry. I mean, it will be 5p2, right?
5 into 4.
5 into 4. Yeah, correct.
Correct. And 3 books, 3 factorial. Are you getting?
Okay.
The same 3 more cases will be like 3 books in the first, 2 books in the second, 1 book in the first, 4 book in the second, 5 book in the first, 6 book, 0 book in the second. I mean, 0 book in the first and 5 book in the second. So you will get 5 factorial 6 times, right? That means 6 into 5 factorial. At the end, you will get 720. Is this correct answer?
Yeah, that's correct, sir. Yeah.
You got it?
Okay.
Yeah. Is there anything else?
So if I just put a question this way, say like 5 books can be placed in 2 bookshelves. If the word arranged is not there, if there is a keyword like placed instead of arranged, so would that make a difference here?
So suppose I'm saying I have 5 books. I can place in.
Yeah, how 5 books can be placed into bookshelves? I mean, if a question is something like that, would that mean? I mean, I don't need to think about permutations in one bookshelf.
Thing is that if we are not considering the within arrangement,
correct,
then
yeah.
I will consider as 1.
Correct, yeah.
If you are going to consider the within arrangement, then I will consider that number of factorial ways, right?
Okay. Yeah, I mean, because that keyword which you explained, which makes the difference. So I'm just trying to understand.
Yeah, it's depends on the framing of the question.
Correct. Yeah.
Correct. So whether I mean the manner of the framing of the question. Okay.
Okay.
Just I think. Okay, I will search more questions related to this. Okay, for this one thing. Okay, yeah, it's a depends on the framing of the question. It totally depends on the framing of the question. In which scenario I want the thing. Okay.
Okay. Yeah, got it.
Yeah. Is there anything else from your side?
No.
I think yesterday was week 5 due date, right? So I don't think all of you have covered the week 6.
Yeah, I mean, week 6 we just started.
Yeah.
We started.
Is
It's
there anything else? So you can ask, and or else we can wind up also if you want. Then you can ask the things. We can discuss. No issues.
So can you explain one more time that same question? I mean, the 5 books and the 2 shelves.
Okay. 1 second. Okay. So 5 books are 2 bookshelves, right? So it's possible there is no book in the first bookshelf.
Yes.
And 5 books in the second bookshelf.
Case 1 it would be 0, 5.
So 0 means what? One way?
Yeah, I mean, case 1 would be like 0 books in the first shelf and 5 books in the 4 shelves.
Second.
Yeah, second shelf.
So that means in how many ways you can arrange a 0 thing? One way?
Yes, 0 factorial. Yeah, one way.
0 factorial, that is 1, right? In how many ways you can arrange the 5 books in the second bookshelf? Hello?
Yes, sir. Yes, sir. 5 factorial ways.
5 factorial, right?
Yes, sir.
Now let me share my screen. Okay. So case 1 will be like that. 0 book, right? In the first bookshelf, right?
Yes,
That means 0 factorial, that is one way, right? And
Yes, sir.
5 books in the second, that is I can arrange in the 5 factorial ways.
Yes,
Okay?
sir. Yes, sir.
So for the case 1, what is the total number of ways? 5 factorial into 1, which is nothing but 5 factorial.
5 factorial. Yes, sir.
Because we have to consider the first bookshelf and second bookshelf, right?
Yes,
That's
sir.
why I'm multiplying the number of ways for the first one and the second one and first one, right?
Yes, sir.
What will this case 2? 1 book in the first bookshelf.
One book, yeah. And 4 books in the sex.
Correct?
Yes, sir.
So in how many ways you can arrange a 1 book in the first bookshelf?
Just one way, sir.
Just think a little bit.
I mean, oh yeah, he can choose any of the 5 books. Yes.
Any of the 5, right?
Yes, sir.
And for the 4, he have 4 factorial ways.
Yes, sir. Yeah. Yes, sir.
Correct?
4 factorial ways.
What is the total number of ways?
Oh,
5
5
into?
5 into. Oh, yeah. Yes. Okay. Yeah. So I will do it, sir. Yes.
Okay. What about case 3? Just tell me the case 3. 2 books.
2
in the
and
first
3.
bookshelf.
Yes, sir.
So and 3 books in the second, right?
Second. Yeah.
So what is the number of ways for the 2 books in the first bookshelf?
Yeah. There would be like
5 into 4.
Yeah. 5.
5 into
4.
For the remaining 3 is the 3 factorial.
Yeah.
Yes.
So at the end I will get 5 into 4 into 3 factorial. That means what? It's again 5 factorial.
Oh, that's again 5 factorial. Yes.
Okay. So similarly, you will make the case number 4. What will be case number 4? 3 books in the first.
3 and 2.
2 in the second.
Yes.
So for 3, how many ways you have?
Same as case
5
3.
into 3 into 3.
5 into 3 into 3.
5 into
Yeah.
Oh,
Yes.
sorry. 5 into 4 into 3, right?
5 into 4 into 3. Yeah.
For the 2 factorial.
2 factorial. Yeah. Oh,
Again,
5
you
to 3
will
to it's again 5 factorial.
It's again 5 factorial, right?
Yeah.
What about case number 5?
Yeah.
4 books in the first.
1 in the
1
second.
book in the second.
Second.
So
Yeah.
4 books in the first means what? 5
Okay.
into 4 into 3 into 2. Correct?
5 into 4
or 1,
into
it's a 1.
3 into 1. Yeah, 1.
Again,
That's
you
again
will
5
get 5
factorial. Yeah. Yes.
So case number 6, 5 books in the first and 0 book in the second. So it's
Yeah.
a 5 factorial. It's a 1 factorial. Again, you will get
5
5
factorial. Yeah.
So this will be 6 times 5 factorial, right? Because
Yes,
you have
sir.
to consider all the 5. So it will be 720.
Oh, okay. Yeah. Thank you, sir.
Yeah, great. Okay. Is there anything else? I think Tuesday is that solve with us session, right? Okay. So is there anything else? Do you want to ask or else we can wind up?
Tuesday is the solve. Solve with
yeah.
instructor session. Yeah.
Solve with instructors. Okay. So is
Yeah,
there
can you
anything
just
else?
give us a brief idea about this 6th week content, because it's getting tougher. I mean, I just went to the 2 videos of second week. I mean, 6th week. And a lot of formulas are there, a lot of concepts are there. Even I couldn't solve like the activity question second. I mean, few questions. I mean, in fact, I couldn't approach it the right way. Yeah. So it's appreciated, if you could explain the concepts there for the 6th week.
Which concept? Can you tell me the concept, because I don't have content for now, because I'm not able to open the. So, can you tell me the topic? Just a topic, if you remember.
I will just get it.
Yeah, just a second, because I don't have the. I mean, I'm not able to open my laptop.
Can you open YouTube? I will share the YouTube videos. I mean, I will give you the videos link.
Okay, just there. Okay, is there anything like that arrangement of same thing like that? I think.
I mean, the second video I found it difficult to understand that circular permutation.
Okay, you are asking that circular permutation. Okay.
Yeah, and that there was linear things and circular arrangements, clockwise, anti-clockwise, then repeated, not repeated things.
Okay, circular. Okay, I will tell. Okay, suppose you have 4 people. Okay, let's say A, B, C, and D. Okay, I want to arrange these 4 people on a circular manner. Okay, or on a circular table. Okay, now suppose this is A, this is B, this is C, this is D. Okay, so there are 2 cases. 2 cases means clockwise and anti-clockwise are different.
Okay. How can we approach it, sir? Like, since we have given the names like A, B, C, D, we know it's clockwise.
No, these are the 4 person. Okay, I'm saying clockwise and anti-clockwise are different. So clockwise and anti-clockwise are different means what? Okay, suppose you are considering A, B, C, D, right?
Yes, sir.
Correct.
Yes.
So what is the meaning of anti? So here anti-clockwise is different. A, D, C, B.
Yes, sir.
Yeah. No, sir. The position may change.
Position. Okay. Suppose I'm saying, okay, I have.
So the entire perspective is like, how we look into it, like, clockwise or anti-clockwise depends on that, right?
Okay. Let me tell you. This is the AC. Let me take like this. This is like, okay. Let me make the cases so that you can understand. This is the A. Okay. Let's say this is the D. Let's say this is the B. Let's say this is the C. Okay. Suppose I want to arrange the 4 people on a circular manner. Okay. So in how many ways we can arrange? First, tell me this. You have 4 people A, B, and C, and D. In how many ways you can arrange these 4 people on a circular manner?
A, B, C, D. Yeah. So that means A is fixed on top, and now we have another condition like D can be fixed on top, or we can approach it like C comes next to A.
One second. Suppose you have 4 people.
Yeah.
And you want to arrange. There are 4 chairs. In how many ways you can arrange these 4 people?
Yeah. Okay. A, B, C, D. Then suppose if A is fixed, then B, C, D. I mean C, B, D. Like that we can count it.
Just tell me the number of ways.
Be 4 into 3. 4 into 3 into 2 into 1. 4 into 3.
There are total 4 factorial ways, right?
Yes, sir.
Okay. Suppose I have A, B, C, D. So it's possible A can be here, B can be here, C can be here, D can be here. Again A, B, C, D.
Yes, sir.
Correct?
Yes,
now, next case can be A, B, C, D.
Yes, sir.
Same. What can be next case? A, B,
in this case,
D.
Yeah. So what is the difference here? Because almost all the cases, D and B are next to A.
That's why just let me finish. Okay.
Oh, sure,
I'm trying to explain the number of ways in which you can arrange the people on a circular table or circular manner, right?
Okay, sir. Okay, thank you.
So here clockwise and anti-clockwise are different, right? If you go clockwise and anti-clockwise, right? So how many ways are there total? 4 factorial for the initial one, right? And there are 4 ways also in which things are same. Correct? Because A can be here, A can be here, A can be here, and A can be here. Are you getting?
Yes, sir. Same.
Are you getting my point?
So you mean all these are considered the same?
Okay. Okay, let me erase, I think. This is the first case, right? I can arrange the A, B, C, D in 4 factorial ways. I can arrange or not?
Yes, sir. You can.
We can arrange, right? Now,
yes, sir.
It's a circular manner. Okay, suppose you are here. You can see A, B, C, D like this. Okay. It's also possible I can see A, B, C, D. Can I say this or not?
Yes, sir.
Suppose you are here. You can see the same manner. Okay. People are same next to each other, right?
Yes, sir.
Suppose A are here, B is here, C is here, D is here. This is the one another case.
Yes, sir. D and B are next.
Okay. What can be next? A can be here, B can be here, C can be here, D can be here.
Yeah.
Okay.
Yes.
So how many ways are we are considering the same?
So we have moved A 4 times, like
4 times, right?
Yes, sir.
So can I divide by 4?
4 factorials by 4.
Manner?
Yeah. Oh, okay.
So what we get? 4 into 3 factorial divided by 4. So 4 will get cancelled out.
Yeah. Yes,
that
sir.
means we are getting 3 factorial, right?
Oh,
Now,
okay.
so thing is that suppose I have n people and I want to arrange, or I have n distinct objects and we have to arrange in a circular manner where clockwise and anti-clockwise are different. Okay. If these two things are different, that means what? As per suppose you have 4 people, so you have done 3 factorial. So for n people, can I do n minus 1 factorial?
Yes, sir. We can do it. Yeah.
I can do it, right? When clockwise and anti-clockwise, these two are different, right?
Yes, sir.
Clockwise and anti-clockwise are different. Yeah.
It's clear.
Clockwise and anti-clockwise are different means? I mean.
Okay. I will give the example. You will get the idea what is the meaning of clockwise and anti-clockwise. Suppose you have necklace. Okay, beads of necklace of the same kind of beads. Okay, suppose this is the necklace. So clockwise and anti-clockwise are different means mirror images are not same. You are going like this or you are going like this. You will get the same arrangement.
Okay. That means on the right and left, we will have the same numbers.
Correct. Same arrangement.
Okay.
Not okay. So you have to think arrangement. Okay. Let me give the example of clockwise and anti-clockwise same or different. Okay. So far, tell me this thing is clear or not?
Sir, one thing which I have doubt on this concept is we considered A, B, C, D. I mean, we rotated the position by keeping that order fixed. Okay. But what about A, C, B, D?
A, C?
I can place it like A, C, B, D, right? I mean, that's also.
No, that is the okay. Okay. Then you have to think like that. A, C, B, D. A, C, B, D. Then what you can do? You can place A here, then C here, then
this is another 3 factorial.
This is the another way. Okay. So this is the one way in which I explained you the concept of n minus 1 factorial. Okay.
Okay.
Okay. So see, these are just I took as a person. Okay. It can be P1, P2, P3, P4, anything, right? So you can do anything. But for this scenario, ABCD or ACBD, you will get the 4 another way in which you can divide them. Okay.
Okay. 3 factorial 6.
So basically, if the question comes like, how many ways can we arrange ABCD in a circular manner, or 4 persons can be arranged in a circular manner, we have to look into all 4 cases, like, we get 4 3 factorials and then multiply it by 4.
Okay, I explained this concept for the way, from where formula came, right?
Yes, sir. In this case, we have considered A to be like we moved it in clockwise and we checked it. Yeah.
So is it clear or it's not?
The formula is clear, sir.
This formula is clear, sir. My question is like, is this a solution for arranging 4-person in a round table? I mean,
yeah. But thing is that you have to think whether clockwise and anti-clockwise are different or
okay,
same, right?
okay. Even if I assume clockwise and anti-clockwise is different, so my question is like, okay, see, we arranged A, B, C, D, and then we derived a formula like n
Okay.
factorial.
You are saying A, C, B, D.
B, D. Is this like another plus?
Yeah, it's a no. Okay, suppose I have done. I take just a scenario. Okay, so you want to arrange these 4 people like this, right? Okay.
Yeah.
So what can we do? Suppose someone came. Suppose Pradeep came and he is seeing from here, right? So he will see A is the left side to. I mean, C is the left side of A. D is the left side of D. A, right?
Correct.
Okay. What I can do? I can do like this also. ACBD.
Yeah.
Suppose Pradeep is here. Again, D is the right side of A. C is the left side of A. Right?
Okay.
What can be the next scenario? It can be A, C, B, D.
Yeah.
Right? Again, A will be here, C will be there, B will be there. So this is
basically in this
again,
case. Yeah, we are not changing the position of
No.
The position of C and the B and D always comes next to A.
Correct.
That is the case.
That's why we are dividing by 4, right?
Yes, sir.
These 4 cases.
Yes.
Okay. Suppose you n people, then means n factorial divide by n. Okay. You will get n scenario. Okay.
Yes.
At the end, you will get n minus 1 factorial when clockwise and anti-clockwise are.
Yes, sir.
Is this clear now?
And there was a concept like mirror image and
Yeah, mirror image. See, what is the meaning of clockwise and anti-clockwise shape? Suppose you have necklace of beads, right? Okay. Suppose you have necklace of same kind of beads like that. Okay. If you go clockwise and anti-clockwise, you will get the beads.
It doesn't matter.
Yeah, you can see the beads. Not beads. Necklace in the same. It's the same
manner. Yeah.
Okay. Clockwise and anti-clockwise are same means if you see the mirror image of your necklace, you will get the same necklace, right?
Oh yeah, yes, sir.
But if you're saying that 4-person ABCD, if you see anti-clockwise, but then you will see the different arrangement, right?
Oh, okay.
Okay.
Anti-clockwise, if we see, we will see a different image.
Yeah,
I don't know.
Different image with different arrangement. Okay.
Suppose there are 4 beads in a necklace, and if we come from the left or from the right, it will look almost the same, right?
Yeah, that's why necklace is the case of clockwise and anti-clockwise same in the same kind of beads, right?
Yes.
Okay, suppose this is your beads necklace, right? Whether you will see by this or this necklace looks same, right?
Yes, it will look same.
Okay, let me give this example so that I think this might be clear. Suppose this is A, this is C, this is the D, this is the B. Okay.
Yes, sir.
For arrangement of the 4 people on a circular manner, A, D, B, C. Okay. So if you see clockwise, anti-clockwise is different, right?
Yes, sir.
In this case. Okay. So what will be the next case? Okay. As per the 4 people, it should be 3 factor, right? And minus 1. So we should get 6 case, right?
Yes, sir.
Right.
Yes,
so
sir.
next can be A, D, CB.
CB, yes.
What will be the next? A,
CB.
A, B, and D, C, right?
Okay.
So it should be A, C, B, D, right?
Yeah.
So these are the total way in which I'm arranging, right?
Okay.
Okay. I can arrange the 4 people when clockwise and anti-clockwise are different, right?
Yes, sir. You can arrange
someone asked that ACBD arrangement, right? if you are saying this AC BD arrangement, then you will get by this, you will get 6 ways. 6 ways means you are including all the cases, right?
Yes,
So
sir.
in all the scenario, clockwise, anti-clockwise.
Yeah, it's all the same.
No, not same.
I mean, six.
There are total 6 ways, right?
Yes, sir. Yes, sir. Six
clockwise
ways, yeah.
and anti-clockwise are different, right?
Yes, sir. Yes, sir.
What is the meaning of clockwise and anti-clockwise? Same means see. Okay, don't consider like this, people. So I'm just trying to explain the meaning of clockwise, anti-clockwise same. So what I can say, if you see, if you go clockwise, ABCD, can this is same as ABCD? This thing is same as this thing?
No.
No, sir, it is a mirror image, right?
No, if you go clockwise, you are getting here ABCD.
ABCD, yes. Here ADCB. Anti-clockwise, yeah.
Anti-clockwise.
Okay. Yeah, anti-clockwise, yeah, we're getting.
For this AC DB.
Yes.
Again
ACDB, yes, sir. Yes, sir.
If clockwise is
ADBC.
same and ADBC, right? So what? Okay. In a way, how many cases you have? If clockwise and anti-clockwise same.
Oh yeah.
I
mean, there are total 3 ways.
That is 6 by 2.
6 by 2, yeah. So yeah, that's how the formula came. Oh, okay.
Correct. So suppose you have n distinct object, okay, and you want to arrange in a circular manner case clockwise, anti-clockwise same, it will be n minus 1 factorial by 2. You can do in n minus 1 factorial by 2 ways. Okay, is this clear?
Yes, sir. Yes, sir. I will watch the video again. Yeah.
Yeah, you will just watch the video again. I think you will get the more clear idea. Okay.
Yes, sir. Yes, sir.
Is this clear for everyone?
Yeah.
Okay. Is there anything
yes, sir.
or we can? Okay, just watch the lecture video. I think you will get the more idea.
I will watch the videos again, sir.
I hope you got
just 4 videos, right? Yeah.
Yeah. I hope you got the funda of the clockwise, anti-clockwise.
Yeah, it's all the things like, how we look into it, like from where we are looking into it.
From where we are looking into it, right?
Yeah.
And you got that why we are dividing by, I mean, instead of
yes.
Okay, this is the difference for this. This is the difference between linear arrangement and circular arrangement.
Circular arrangement. Yeah.
If you are arranging in linear arrangement, you will get n factorial.
Yes, sir.
For the n objects. Suppose I want to do in circular arrangement. In that scenario, I have to divide by n.
N, yeah.
Then I will get n minus 1 factorial, right? If it's
yes,
clockwise and anti-clockwise are same, that means cases will be half.
Cases will be half, yes. Sir.
I
mean, clockwise, anti-clockwise, same means that will be a mirror image, yeah.
Yeah, mirror image are same.
Mirror image. Yes, sir. Yes.
That we have done for the like this this case, right? This
yes,
black.
Yes, sir. Yes, sir. Understood, sir. That part.
Okay. Then.
Okay. If I watch the videos one more time, I will get more idea about it.
Yeah, you will get more idea. No issues. You have enough time. I think Sunday is there, Monday is there, Tuesday. There are 3 days.
Yes,
sir. Sir, one final question from my side. So on the beats problem that you explained, right? So if a question is like say 8 beat, I mean n beats can be arranged in a round table, around a necklace, then it is n minus 1 factorial. If we consider that clockwise and anti-clockwise are
in case of beats,
n minus 1 by n factorial by 2 because it's a same thing. But if the question is like 8 different colored beats, then in that case it will be n minus 1 factorial.
Yeah, you can think, because if it's a different color, that means if you see mirror image, you will get the different
order.
Yeah. Okay, so just clear with the statement of the question.
Okay? Yeah, sure, yeah. Okay, sir. Yeah.
Okay,
thank you, sir.
Then. Yeah, thanks. Bye, everyone.
Thank you, sir. Good night.
Hope you got the concept.
Yes, sir. Understood.
Yeah. Okay, thanks.
Do we have any other session in middle, like by Monday or before this solve with the instructor session, sir?
Maybe by TAs, because I need to check with Mayur sir, because
okay.
Yeah,
it's needed, sir.
Okay, great. Okay, I will. Okay, there is problem solving session is going on, right?
Problem
sir.
solving, yeah,
Problem solving.
yeah, it's there. You know, one in the morning, that's for the solve with the guy.
There is solve with us on
and another one is in
TA.
the evening. That is for the doubt clearing session. You know, I am unable to attend the doubt clearing session so far because of the transport issues in my job. Yeah.
Okay.
So
Okay.
I
Okay.
always attend that morning thing.
Hmm.
Yeah, and
Okay. So I will ask with the team if it's possible. You will get the notification related to the session. Okay.
yes, sir. Thank you.
Thank you.
Oh, okay. Thanks.
Sir, excuse me, sir.
Yeah.
Sir, when will quiz one result be announced?
It's not yet, right? Yeah. You can. I think you can expect soon, within 2 or 3 days maximum. I think.
Okay. Okay, sir. Thank you.
Yeah. Okay then. Thanks.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Bye.
Thank
Good
you,
night.
sir.
Yeah. Just watch the lecture video and we solve more questions on permutation combination.
Yeah.
Okay.
Yeah,
Great.
sir. Yeah.
Yeah. Okay. Okay. Thanks. Thanks. Everyone.
Thank you.